I'm Marcia.
I'm Sarvajit.
Christine.
I'm Frida.
And we're Team Bacteria, and we are going to be modeling the classical complement pathway. So, as you can see over there, and just for reference, we put up this PowerPoint just so that you guys can kind of collate our protein crystal structures that are so wonderfully demonstrated in our pipe cleaners with the colors that are up there. So it kind of all starts off with an antigen modeled by our balloon with nice little fuzzy epitopes. So this is just kind of floating along in the circulatory system.
And then IgM or subclass IgG comes and binds and cross-links with the antigen, having the Fc regions being revealed.
And that's when your C1 molecule comes in and it recognizes the Fc receptors of the IgM or IgG, in our case IgM, and it gets activated essentially.
And then C4b and C4a come together and then get this attached. C4a is attached.
And same happens with C2, where it comes in as a component and then cleaves off vertically into C2a or C2b and the C2a component. And now we're just going to basically zoom in on the surface of the microbe to this. This is essentially what the cell membrane would look like. And so C2 and C4 would actually create a complex.
And that would become the C3 convertase, and C3 comes in, and C3 becomes C3A and B. A walks off, and C3B can either become part of the milk, or it can also attach to the microbe itself.
To optimize it.
But in our case, it'll form a complex with the C4b, the C2b, and then the C2b gets attached on to form the C5 convertase.
C5 becomes part of it, and C5a pops off as well.
And so now we have our C5v that's been proteologically formed by the cleavage, and this just kind of floats off. Now, C6, C7, and C8 are all actually found in circulation, like in the extracellular part of the circulation, as individual molecules. But for the sake of simplicity and for time, we just kind of complex them together into C6, C7, C8 complex, because that's actually what ends up happening. And what this complex does is it actually gets anchored into the plasma membrane itself of the antigen.
And C5 comes and becomes part of.
So C5 actually induces all this complexing, and C8, the last complex, initiates C9 formation, polymerization, into a, this basically forms a perforin ring to lyse the microbe.
To lyse the microbe up. And this entire complex actually starts the polymerization of it. And once this forms, the antigen essentially lyses and it explodes. Now, not quite done yet. Now, there's more. There's more to this part. Now, if you guys remember, we have all these little A globulins. That's us here. So what actually ends up happening, and if the volume were louder, you would actually see that inflammation occurs. So, inflammation. And there's supposed to be fire sirens going off, but because we don't want to disturb the classroom over there.
I missed the inflammation. Sorry. There. Okay. Got it.
And one last thing that happens is C5a actually acts as a very good chemokine. So if you guys are essentially our phagocytes, these can be modeled as C5a chemokines.